Welcome to the third episode of Under the Hood. So back in April 2018, we released the first version of Business Central in the cloud. That was the first time we had Business Central as a true SaaS offering, as a true SaaS service. And since then, we often got the question, how many users can Business Central handle in the cloud? So today in this episode, we are going to answer that question. And to help me with that, I have Christian with me. Hi, Christian.
Hello.
So Christian, you know a little bit about cloud technologies, right?
Yes, I would say so.
Yeah. So you've been working with these Business Central and the whole cloud thing since the very beginning, right?
Since day one of when Windows Azure was still a new thing, and we thought that would be an interesting technology. Yeah, I was part of that journey.
So very early, you
more than 10 years ago.
Yeah, you started experimenting with Azure technology. So it's fair to say you're an expert in cloud technologies, right?
Maybe yes.
Yeah. So today we are going to go really under the hood. You're going to see some things that you don't normally see with Business Central because some of the machinery that is in the cloud is not publicly documented, but we are going to talk a little bit about it with Christian today. So let's start with topology. Let's start with that. So how is that different from, for example, on-prem?
Yeah, so on-prem you would maybe typically have the NST installed on one machine, a physical machine, and the database maybe on a separate machine or maybe on the same machine in a simple setup like this, and they would be very close to each other and you would manage everything. In the cloud we do things differently. First of all, Microsoft, host everything, and we use Azure technologies. So as you can see in this picture, I've illustrated a very simplistic picture of our topology in the cloud.
So that's how it looks like in the cloud.
That's how it looks like, very, very simplified. So, but enough to explain what we're going to talk about.
Okay.
So we have a VM cluster. Technically, it's a virtual machine scale set that has a number of VMs. And all our VMs are configured in the same way. They run the web server and they run the NST. And we typically have, we have from 5 VMs and up in such a cluster. And then you have users logging into in the browser, and you have systems that call our APIs, and when they call, we have a load balancer that we implemented that understands Business Central, sessions and things like that, and it decides which VM should handle the request, and it forwards the request to the right VM.
So it's not always the same NST, so to speak, that handles the request.
No, so 2 sessions can be for the same customer, for the same environment, can be handled by 2 different VMs. When you have a UI session that is that lives for minutes or hours or more, it will stay on the same VM though, because we don't move an existing session from one VM to another.
So what happened when there are many users on the cluster like this, like doing things at the same time?
Yes, so we have those VMs that we have. Let's say we have 5 VMs, and as more and more users log into the system, or maybe we have job queues running or APIs being called, over time the load will increase on the virtual machine. Like say in the morning, people come in, the load is very low, but over time the load increases. So at some point we say, this is too much for a given VM. We are not comfortable with sending more traffic to the VM. So I can illustrate what happens. So our load balancer continuously keeps an eye on these VMs. So it looks at the CPU load, for example. It looks at memory. It looks at other things too, but I'm just using CPU here for illustration purposes. So it will always know what the CPU load is on each VM. And then we say we have set a threshold at 60%, and if a VM goes above 60% CPU load, we say it's starting to become overloaded, even though 60% is far away from 100%.
Why did we choose 60%?
There's no rule for this. It's based on experience.
Mm-hmm.
It's low enough that we have a good reaction time. It's far away from 100%, but we also want to, of course, utilize the VMs, so we don't want to set it too low either. So it's like the compromise.
But we still have 40% available.
Still have a lot of capacity left at this point.
Okay.
But when this happens, what our load balancer will say is, let's give that VM a break and not send new sessions to it. So the existing, as I explained before, existing sessions, we don't move them. Mm-hmm. They keep running. But any new session will go to, let's say, VM1 or VM3 and thereby we give VM2 a break, and as the load, as the sessions on this VM start to finish what they were doing, the load, we should expect the load to drop on the VM below 60% again.
Okay. So what happens if all VMs get busy? Like if there's really a lot of activity, everybody's working hard, doing a lot of sales order or something, and then all the VMs get above 60%. What happens then?
Yeah, it happens all the time. If that happens, we add more VMs. As simple as that.
Okay. So we have like practically infinite number of VMs.
Yes, so
it's the Azure cloud, right?
It is, and a normal VM cluster, we always have at least 5 VMs, but it's very normal that we have 10 or 20 or 30 or 40 VMs in a cluster. So yeah, it can scale as needed.
And what happens when everybody goes home afterwards? And then we have all these VMs, they do nothing.
Yes, so we might scale out aggressively, add more and more VMs very aggressively. We also scale in again. We do that, very slowly. But we will slowly remove VMs again.
So we add more. You add VMs faster than we remove them.
Yes. So we want to see we have had a very low load on the cluster as a whole for a long time. It's now safe to remove a VM. So we do that.
Okay.
So I have some illustrations to show you how this works in sort of in real life, to give you a feel for how it really works.
So these are real life data.
These are actual
from
clusters.
Telemetry.
Yes, these are actual clusters. So here we have a cluster with 9 VMs. So each VM is represented by a color, and this is a cluster in the US, and the time was 5:35 UTC time. So it means it was very late evening in the US, close to midnight. And as we can expect, there's not a lot happening that at time of day in the US. So the VMs are not doing much. The turquoise one is doing a bit of work, but the others are not doing almost anything.
But it's still about 20% or something. So
yes.
It's not a lot of work.
They're not doing much. And so if we go 1 minute ahead, we can see that all of a sudden
something's happening. Yeah.
Something is happening. The blue VM and the orange VM start to do a lot of work. We cannot say what type of work it is from this picture. It can be job queues, it can be users logging in the evening, it can also be API calls. Maybe they have some integration that runs.
Yeah, maybe they copy some data in a batch thing or something.
Could be, yeah. But still we are at 50% load on those 2 VMs. If we go 1 minute further ahead, we can see the load continues to rise, but still below the 60%. Still fine. 1 minute later, we can see that the blue VM crossed the line, and as I explained before, at this point, the load balancer will say no more new sessions on this VM. Instead, it will create new VMs on another VM, and it looks like it picked the purple VM in this case.
So does it have to be over 60 for like 1 second or 2 seconds? Or if it's just reached one, like for a millisecond, are we going to add a VM?
No, we're not going to add VMs as that aggressively. For deciding to use another VM, yes, it's immediate. If we see it's above 60%, we will start to use another one. We want to react very quickly to this. So if we go 1 minute further ahead, we can see, as expected, the blue one starts to drop again because it finished the work that it was doing, and we didn't send new work to it, so it starts to go down again. Yeah. But we can also see the orange one and the purple one, they crossed the line now, and the load balancer already reacted and sent traffic now to the, I think, dark blue and dark green VMs here, and so they are starting to do some of the work. And so it goes. The next minute they all dropped, and maybe this was it. I don't know what happens after this, but maybe that was just a 5-minute burst of activity in the US in the evening.
But it doesn't matter. We don't need to know.
We don't need to know. So this is how it works. So it might hover above 60% for a little while. You can see it goes maybe to 66% at its worst here. And that's fine. Still plenty to go until we reach 100. And that's how it works. And I also have an illustration about how we scale out. Yeah. Just to give you a feel for how that works.
Yeah, let's see that.
So here we have another cluster. This one has 24 VMs.
So this is in Sweden?
This is in Sweden, yes. And we can see the time is 8:08 in the morning UTC time. So that would be 9 a.m. approximately in Sweden. And if we go 1 minute forward, we can see all of a sudden, like some coordinated action in Sweden, I don't know. They all start.
People come to work, they have their coffee, and now they probably start working, right?
Yes, that's the time they come to work in Sweden, apparently.
Yeah.
And they start to do some work, and we can see some VMs have crossed the line above 60%. And if we move minutes ahead, we can see, it's getting, all the VMs are getting pretty close to 60%. Some are above, and some are not. But the model works the same way. So we can see that it hovers around 60% when a VM goes above. The load balancer redirects some traffic to other VMs. So therefore, they will all start to hover around 60%. But what we can see here is we are getting close to the point where we need to add more VMs basically, because if they are all above 60%, it's too much, and we need to have more VMs. And this happens. We have an algorithm, and we're tuning that all the time. But in this case, we can see in our telemetry that at 8:12, it said enough is enough. We need to have more VMs.
So we all the time looking at this algorithm, and we started with one model, and we fine tuning it all the time to provide the best experience for our customers. Right?
Yes, exactly. Yeah. So at 8:12, we say we need 3 more VMs. Again, the algorithm which we change from time to time. In this case, it would say 3 more VMs is the right number. So it requests from Azure to have 3 more VMs.
How long time did that take?
Yeah, we can see in this case it took 10 minutes and then 11 minutes before we got the last 2 VMs. So after 11 minutes, we have 3 VMs that are ready now.
Fast.
It's okay. Yeah, it's enough, because we still have, in a whole cluster with 24 VMs, we still have 40% buffer above the 60% that they
So just to be clear, it's not like people are waiting 10 minutes for the work to be done. They still have VMs. They're a bit busy. So they continue working as they don't see anything.
In this case, there were no problems at all, because each VM still had a 40% buffer. Right. So as we know from our own laptops, that's fine. Yeah. It's fine, no problem, right? And because we have this big buffer, it's also plenty of time to create new VMs, so we can handle a sudden burst in traffic. Even if they are pretty loaded, we can handle a burst.
Okay. So what you're saying basically is that in terms of VMs and compute, there's no problem. We always have capacity.
Yeah, I would say we are pretty mature in this area, and capacity is rarely the source of a performance problem.
So how about database? How about the database? Can that be also a bottleneck for performance?
Absolutely. It means pretty much the same picture, and I have an illustration of that too. So we monitor our databases as well, and we monitor CPU load, I/O, data I/O, log I/O, and other things. And if we see that it gets above a certain threshold, we say that database needs more capacity, and then we give it more capacity.
We also have an algorithm there for that monitor certain metrics to scale the database as well. Yeah.
And I have an example here of a database where you can see the database was not doing anything until suddenly it started to do something. So maybe they had some kind of a batch job.
So that's also real world.
This is real world. Yeah. And they run, and then they pause for a minute or two, and then they run again, and it goes to 85% perhaps CPU. So again, it's not like it's suffering, right? It has necessary capacity, but we're not comfortable with this situation. So we decide at some point to add more capacity to this database. So after 30 minutes, we see this is enough is enough. We want to add more capacity, and so we do. And the pattern for this database seems to continue in some form. You can see they do some more rounds of this pattern. 2 more rounds or something like that. I'm not sure it's the same thing that's happening, but it looks like it's the same. Could be the same, because the CPU load dropped to approximately half of what it was before, and we doubled the capacity of the database.
So it sounds like they're continuing doing some work on this database.
Exactly.
Somehow.
It adds up.
Yeah. So you're saying there's no capacity problem with the compute, and we also, because we can scale, and we can also scale the database if there's a lot of activity. So how come we hear reports every now and then that our customers, they have, they think they experience BC as being slow. So
Yeah.
How come? If we don't have, you're saying we don't, we have this practically infinite amount of resources in the cloud. So how come users are experiencing sometimes slow performance?
Yeah. So the source of a performance problem can be a million things.
Okay.
But we have some things we see all the time that are sources of these problems, and it typically has to do with AL code and the way it uses the database.
Okay.
Because many problems are because of database queries.
So mostly database.
Yeah, mostly
and
database.
AL code.
Exactly.
Okay.
Yeah, and I have an illustration to show you the typical problems we see.
Okay.
So here we have again the VM clusters that run the AL code, and we have a database. And the three categories are: the first one is logging, database logging, which we are all familiar with. So one session takes a log on a record, for example, and another user wants to take the same log, but they can't, so they have to wait. And while they are waiting, the UI is slow. So that's one source of problems. People stepping on each other's toes, so to speak.
That's not a cloud problem, is it?
No, that's just how databases work.
It's also something we know from the on-prem world. Right?
Yes, exactly. The other category is long-running queries. So this typically happens when you have a lot of data, like you have a table with many millions of rows, and then maybe you do a search and you're missing an index typically, so you have to read all the rows, or the database has to read all the rows, and that can be slow.
Okay.
And the last category is many short queries. So for example, if you iterate over, you have maybe thousands of sales orders or sales lines, and somehow in your code you have an iteration over these, and for every iteration you make a database call. Yeah. So even if each database call is just 1 millisecond, if you have thousands of them, it adds up to multiple seconds, right? And so you can feel it in the UI. So those are the three sources of performance problems we see most often.
So are there patterns which are actually worse in the cloud than on-prem?
Yeah. So you can see all these patterns on-prem as well. But the third category, many short queries, I would say it's probably typically worse in the cloud, and that is because, as I explained in the beginning, on-prem, the database and the NST are practically next to each other. Yes, so the latency there is zero. But in the cloud, with buildings, data center buildings far apart, there can be a latency, typically less than a millisecond, but it's there.
Yeah, times a million, it becomes significant. So something you wouldn't be seeing in a co-located environment on-prem becomes actually a problem in the cloud.
It can happen, yes. So the recommendation is to try to avoid that, which will also help, of course, on-prem. So it's just a good thing to not do unnecessarily.
It's good to do that on-prem as well too. Yeah. So how can I troubleshoot these performance issues? How can our developers troubleshoot these issues, these performance issues?
So over time, we've built up a number of tools, and I want to highlight 4 tools today. Okay. And the first tool is the in-client performance profiler, which is my go-to tool for these kinds of things. Then we have 2 pages in the product that you can just open, the database logs page and the database missing indexes page. And finally, we have telemetry with application insights, where you can also troubleshoot some performance problems.
Okay, we'll put some links in the comments for the documentation of these tools. So yeah. So let's start with the in-client performance profiler. Tell us a little more about it. This is a tool which is in the product.
Yep, it's in the product. Any user can open it.
You don't need to install anything. It's just there.
It's one of the nice things about it. It's always there. So no preparation, no installation. Let's look at it. So this is how it looks. In the lower left-hand corner, I've illustrated how you open it. You go to the help and support page and then analyze performance, and then it opens up. And it's very simple to use. So you click start, then you repeat the slow scenario. In this case, I tried to post a sales order. It took almost 6 seconds, which is pretty slow.
So you turn it on, you turn the profiler on, and you run your scenario that you observe is slow.
And then you press stop, and then it gives you the result. And in this case, it said it took 6 seconds, and it shows also immediately that is the base application that is using all the time, and a few other extensions are also using a bit of the time. And if you want more details, you can toggle this toggle below, and you can see, for example, which method was using a lot. You get a tree view, for example, of the call stacks in your code, in your AL code, and you can see where the time was spent.
So you can pinpoint the exact method where.
Yes.
So if I have, let's say I have, so in your example it's the base app, right? But if let's say I have a bunch of extensions installed on my system, and then I will be able to see which extension is giving problem performance. That would be, I would see.
In the first graph here, immediately you will see, let's say you install an app source app and it has some bad AL code, you will immediately be able to see this from this picture.
So pretty powerful tool.
I think so.
So you mentioned also database lock.
Yes. Yeah. So if you think you have a database, a problem with logs in the database, we have this page in the product, database logs page. Again, you can just go and open it
It's
at any
in
time.
the product. It's just there. Yeah.
In this case, we don't have any logs in the system, but if you have logs, it might look something like this. So how it works is when we open it up, we ask SQL what logs are currently being held in this database and who is waiting to get a log right now. And if you press F5, it's going to ask SQL again and say, now it looks like this. So you get a point-in-time view on logs and waiting for logs in the database. So in this case, we can see Nestor Wilk has been granted a log on a key of the mixer table, and he was on the mixer list page, and it was the on-action trigger that did it, for example, right? This is an example, right? And you can see that Deborah is currently waiting for a log, so she's probably not happy right now because she's waiting to get a log. So now you already know more about why Deborah has to wait.
So you know where in the code, in that case, in the trigger, you can go in the trigger and try to optimize the code. So
take the log, hold the log for shorter, or maybe avoid it altogether.
Okay. So that was about the locking, and around the database there was also something about indexes and missing indexes.
Yep. So we have the database missing indexes page, and here I don't have a good example. I only have this example where it's one of our tables, system tables, that was missing an index, which we then added. So you will not see that again. So the way this works is when you run a database in Azure SQL will monitor your database, and it will do these thought experiments where it will say, what if I add this index? What would that do to performance? How many queries would it help? How much faster would they execute? The positives, but also how expensive will it be to maintain this index, because it is not for free to have an index. It has to be, there's one more thing to maintain for the database.
And that's something that SQL does by itself in the background. You don't have to do anything. You don't have to turn it on or anything. Something that SQL, it's a feature of SQL. Right?
It is a feature of SQL. It just does it in the background. And what we can do, similar to the database logs, is we can query into SQL and say, what recommendations in terms of indexes do you have? And that's what you can see in this view. So the reason I don't have a good example is because you need to actually run for some days and have a problem for it to make that conclusion and say, I recommend this. So as a partner, if you have a customer database, I encourage you to go and look, and maybe you will see some real recommendations.
Yeah, and when you actually add that index, it usually makes a big difference.
It can mean the world, yeah.
All right, and then so that was about the database, and finally you also mentioned application insights.
Application insights, yes. So this is something I recommend all partners to do, is enable application insights on their environments, which they can do in the Business Central Admin Center. You learn a lot about what's going on in the service, because as we run, whenever something interesting happens, we emit an event to your application insights.
Application Insights is a Microsoft product, which is not only for BC, but a lot of other products are using it. Right? You can use it for practically anything.
Yeah, it's very popular. Yeah, and Azure service also. And so here we have an example where we can see that we get an event that a SQL statement was executed. We can see that it took 4 milliseconds, which is not super fast, but also not very slow. And a note here, normally we would not emit these events when a SQL query takes less than 750 milliseconds, because if we did, we would just overflow the application insights, because this happens many times.
So how do I enable application insight? How do I turn it on?
Yeah, so that's what I have illustrated in the lower left corner. You can do that in a UI session today. That's the trick. You go and enable additional logging, and for the duration of this session, it will emit all SQL statements to your application insights. So you will see a lot of events in your application insights. But now you can query it. So if you have a suspicion that you are doing many calls and you're not quite sure what they are, you can enable this and you can see if this is really the case, and you can sum the durations and see, this is the reason it took 5 seconds. You can also see further details. You can see the exact SQL statement, and you can see where in the code it was executed. So now you are well suited to maybe go and fix the problem.
So pretty much in all the tools you mentioned here, we can trace all the way back, trace the problem all the way back to the code and see where the problem is.
Yeah, so these are troubleshooting tools, right? They pinpoint the problem. They don't necessarily say how you can solve it.
You need to find a solution.
You have to use your own skills there. Yeah.
So Christian, how many users can BC handle in the cloud?
So we don't have a hard limit. So we have customers with hundreds or thousands of users. Adding more users is not really a problem, because we just scale out and add more capacity, except for one area, which is logging, where the more users you have that work at the same time, the more likely they are to step on each other's toes, and one does something and the other has to wait for the first thing to finish. And again, this has a lot to do with how the AL code is written. So if you can rewrite it in a way that it does less logging, then it will also unlock scalability in terms of more users.
So I guess the answer is it depends.
It depends. It depends a lot.
But do you have some examples of what actually the Central can handle?
And we also have a website now that you can go and look at yourself. And I took a few examples from it. So the last example here is number of users. As I mentioned, we have customers with more than 1,000 of users, more than 1,000 users. Many customers with more than 100 users. So not a problem. Some other examples, and there are more in the article.
So this article is a scalability guide that we released recently. We'll put a link in the description so you can take a look at it. And these examples are in there.
These examples are in there, and these are examples of real customers that did something or have something. Like, for example, the first line, 5,000 sales invoices posted in 1 hour. It's a real example from some customer. We don't know who it is, but we can see that a customer posted that many invoices in 1 hour, and there are more examples here. There are also examples of how many API calls you can call, which is quite a lot, I think. So most customers will find that this is plenty, and that's maybe also one of the goals with this, is to give some confidence to partners that they can bring large customers. Like, if you are a partner and you have a customer that maybe needs to post 1,000 sales invoices in an hour, maybe you look at this number and you say, that's probably not going to be a problem, because we have other customers that do much more than that, and so they should be comfortable to bring that customer to the cloud.
But still, if I'm a partner and I have this customer with many users, and I know they are going to do some pretty intensive operations simultaneously on BC. So I'm a little bit worried about maybe a particular scenario. It could be something like, I don't know, time registration. I know that they have some, very high load periods where there's a lot of activity on the system. Well, is there anything I can do to get more confidence?
Yeah, so if you are concerned, if you are bringing a large customer and you want to make absolutely sure that they will run fine from the day one in the cloud, you can test it out. So you can simulate. We have a toolkit for that. It's called the Performance Toolkit, and it is designed one of the main goals is to do the what if scenario. What if I have a customer that does this many sales orders with this many users, and whatever scenario they might have, you can simulate it. You can simulate it to say I have 10 users, they do 10 sales orders per hour each, or whatever the scenario might be, and then you can run it, and you can run it in the cloud, so in our service.
Can you run with like 1,000 users if you want?
Yeah, in principle, yes.
Yes.
Yeah. While it runs, you can also log in yourself, right? It's running in an environment just like any other environment. And you can log in, and you can see, you can use the database logs page, for example.
The tools all the tools you mentioned before, can you use to troubleshoot the system? Yeah?
To see what logs are being held. Maybe you use that to go and change some code. You can see telemetry. You can also just log in yourself and see how does it feel. What if I also now create a sales order and post it? Does it feel fast while many users are doing the same thing in the background? So you can boost your confidence for that customer by using this performance toolkit.
All right. Thank you, Christian.
Welcome.
I hope you found this useful. Again, we'll put some links in the description with all the tools that Christian talked about, and also to the scalability guide. Thank you for watching, and see you next time.